Welcome to this video where we will cover the booklet on grade 6 to 7 revision, which is Set A. Question 1 says the table shows some information about the heights in centimetres of some trees. Draw a box plot to represent this information. So you've got the minimum, which is 10, lower quartile, which is 26, median, which is 36, upper quartile, which is 41, and maximum, which is 55. So we're going to first plot the minimum here. So the minimum is at 10. So we're going to draw a vertical line at 10. Then the lower quartile is at 26. So each square is going up in ones. So that means 26 is plotted here. The next one is the median, which is at 36, which is here. Then we've got the upper quartile, which is 41. And then we've got the maximum at 55. Then we draw horizontal lines between the three vertical lines in the middle. And then we join the two ends either side to form a box plot. Question 2 says a histogram is drawn to represent the heights of a sample of women. 3 of the 4 bars are drawn and shown in the histogram. The bar 4 where the height is greater than or equal to 170 centimetres, but also less than or equal to 180 centimetres, is missing. There are 74 women in the sample. We need to complete the histogram. So the first step is to calculate what these frequencies are. So frequency density is equal to frequency divided by the class width. So if we multiply both sides of the equation by class width, we'll get that the frequency is equal to the frequency density multiplied by the class width. So to find out what the frequency is for this section here between 150 and 155, the width is 5 and we've gone up by 2, so 2 times 5 is 10. So there are 10 people in this first section. Then we've got 155 to 165. That width is 10 multiplied by 3, which is 30. Then we've got 165 to 170. That width is 5 multiplied by 4, which is 20. So 10 plus 30 plus 20 is equal to 60. But we're told that there are 74 in the sample. So if we do 74 subtract 60, this is equal to 14. So there needs to be 14 in this last section here between 170 and 180. Now what we can do is we know that the class width is 10 between 170 and 180, and we know that frequency density is equal to frequency over class width. So if we've got a frequency of 14 divided by a class width of 10, this is equal to 1.4. So we go up to 1.4 on the graph. Each is going up by 0.2, so 1.2, 1.4, and then we draw a box at that section there. Question 3 says the equation x cubed minus 4x plus 1 is equal to 0 and can be rearranged to give this iterative formula here. Starting with x naught, which is equal to 1, use the iterative formula 3 times and find an estimate for the root. So x naught is equal to 1. So to get x1, what we need to do is go to the calculator, input 1 into the calculator, press equals, then clear the calculator, and this is stored as the ANS function. So we're going to replace this xn with ANS. So fraction button, then ANS, this is cubed plus 1 over 4. So this will tell us what x1 is. So x1 is a half, or 0.5. x2, we're just going to press equals again. This gives us 0.28125. And then finally, for the third iteration, we're going to press equals again, and this is equal to 0.2555618 286. And when we're doing iteration, we need to write the full calculator display. So that is part A. And then for part B, explain why this iteration converges to a single root. So the answer to this is that each iteration estimate moves closer to where the graph crosses the x-axis. So when the graph crosses the x-axis, that is where there is a solution. Question 4 says g is directly proportional to the square root of h, where g is equal to 18 and h is equal to 16. Find the possible values of h when g is equal to 2. So g is directly proportional to the square root of h. So to write this as an equation, we replace the proportionality sign with an equal sign, and we add a constant of proportionality, which is k. So g is equal to 18, and this is equal to k square root of 16. So 18 is equal to the square root of 16, which is 4k. And then if we divide both sides of the equation by 4, k is equal to 18 over 4, which is 9 over 2. So k is equal to 4.5. So we can rewrite that in this formula here. So g is equal to 9 root h over 2. And it says find the possible values of h when g is equal to 2. So 2 is equal to 9 root h over 2. So we just solve the equation for h. So multiply both sides of the equation by 2 to get 4 equals 9 root h. Then divide both sides of the equation by 9 because this is 9 times root h. So 4 over 9 is equal to root h. And then to get rid of the square root sign, we're going to square both sides. So this is equal to 4 squared, which is 16, over 9 squared, which is 81. So that is our final answer. Question 5 says rationalize the following fraction. We've got 5 plus 2 root 3 on the numerator and then 2 plus root 3 on the denominator. So we're going to multiply the top and the bottom of the fraction by 2 minus root 3. So we change the sign in the middle between the two terms. So 2 minus root 3. So to expand this double bracket here, we've got 5 plus 2 root 3 times 2 minus root 3. We're going to use the grid method. So we've got 5 plus 2 root 3 and then 2 minus root 3. So 2 times 5 is 10. 2 times 2 root 3. 2 times 2 is 4, then root 3. And then we've got 5 times negative root 3, which is negative 5 root 3. And then 2 multiplied by root 3 times root 3, which is root 9. So you get minus 2 times root 9, which is minus 2 times 3, which is equal to minus 6. So writing these out in a line, we've got 10 minus 5 root 3 plus 4 root 3 minus 6. So 10 minus 6 is 4. And then we've got minus 5 root 3 plus 4 root 3, which is minus root 3. And then on the denominator, we're going to expand these two brackets out. So we're also going to use the grid. So we've got 2 plus root 3, 2 minus root 3. So 2 times 2 is 4. 2 times root 3 is 2 root 3. 2 times negative root 3 is minus 2 root 3. And then root 3 times root 3 is root 9, which is just 3. So this is equal to minus 3. So we write these terms in the middle out in a line. We've got 4 plus 2 root 3 minus 2 root 3 minus 3. So 4 minus 3 is 1. And then 2 root 3 minus 2 root 3 cancel to give us 0. So this is over 1. So 4 minus root 3 over 1 is just 4 minus root 3. So that is our final answer for question 5. Question 6 says find the equation of the line that is perpendicular to y equals 2x minus 6 and passes through the point 1, 3. So we've got this equation y equals 2x minus 6 So therefore m, which is the gradient, is 2 for this line. So for the line that is perpendicular to this line, so m perpendicular, we do the negative reciprocal. So the negative reciprocal means stick a negative sign in front of it and then flip the fraction. So this is technically 2/1. So flipping the fraction would give us a half. So negative a half is the gradient for the perpendicular line. And now we need to work out what c is. We've been given a point which has got x and y coordinates. So we're going to substitute these points into the equation and solve for c. So 3 is getting replaced for y, and then we've got minus a half times x, so minus a half times 1 plus c. So 3 is equal to negative a half plus c. So we're going to add a half to both sides. So 3 plus a half will equal c. So this is 3.5. So that is, as a fraction, 7/2. So the final answer is y equals negative a half x plus 7/2. Question 7 says convert 2.5 recurrent to a mixed number in its simplest form. So to do these types of questions, we need to say let x equal 2.55555 and so on. Then we go to 10x, and this is equal to 25.5555. So what we're doing here is we're timesing both sides of the equation by 10. So by timesing 2.5 by 10, we move the decimal place 1 unit to the right. And every time we're looking to see if we get a match on the right hand side of the decimal point, which in this case we do for the first 2 lines. So we're going to do line 2 subtract line 1. So 10x subtract x, which is on the left, and then 25.5 recurring subtract 2.5 recurring. This means that the recurring sections of the decimal cancel out. So actually 10x minus x is 9x, and 25 minus 2 is equal to 23. And now we solve for x. X is equal to, dividing both sides by 9, 23/9. So that is our final answer. Question 8 says there are 10 counters in a bag. 4 of the counters are red, 6 of the counters are blue. 2 of the counters are taken from the bag without replacement. Work out the probability that 1 counter of each colour is taken. So we're going to draw a tree diagram for the first pick and the second pick. So the 2 possible outcomes are either red or blue, and this is true for the first pick. Then we draw more branches coming off from those branches, labeling red, blue, and this is for the second pick. So the probability of picking a red initially for the first pick, there are 10 counters in the bag and 4 of them are red. So 4 out of 10 is the probability for picking a red on the first pick, and then for the first pick of a blue counter, we're going to get 6 out of 10 because all probabilities need to add 1, and it also tells us that 6 of the counters are blue. Now each counter is taken from the bag without replacement. So that means without replacement means we're going to deduct 1 from the total because now there are only 9. And that means if we've already gone down this path where we've taken a red, that means we'll have 1 less red. So we'll take 1 from the numerator. So 4 minus 1, which is 3. So 3 out of 9. And then all probabilities need to sum to 1. So if we've got 3 out of 9 here, we must have 6 out of 9 for the blues. The same is true for the blue root. We're going to deduct 1 from the total and also 1 from the numerator. So 5 out of 9 is our second probability of picking a blue, given we've already picked a blue. And then all probabilities must add to 1. So this red will be 4 out of 9. Now the question is asked, work out the probability that 1 counter of each colour is taken. So that means we're going to do the red-blue root and then the blue-red root. So the probability of a red and then a blue is 4 out of 10 times 6 out of 9, which is 24 out of 90. and then the probability of a blue and then a red is equal to 6 out of 10 times 4 out of 9, which is 24 out of 90. Then we're going to add these two probability events together, so 24 over 90 plus 24 over 90, which is equal to 48 over 90, and if we divide top and bottom by 6, we can simplify this fraction. So we're going to get 8 over, and then just to check, 90 divided by 6 is equal to 15. So the final answer is 8 over 15. Question 9 says, this sketch shows part of a graph with the equation y equals pq to the power of x, where p and q are constants. The points with coordinates 0, 8, 1, 18 and 1.5k lie on the graph. Calculate the values of p, q and k. So you've got 3 coordinates here, 1, 2 and 3, that all have x and y coordinates. So if we just consider this first equation, we've got 3 equations that we can set up with 3 unknowns, p, q and k. So the equation is y equals pq to the power of x. So if we substitute in these values here, y is equal to 8, p we don't know what that is, q we don't know what that is, but x is 0. Now anything to the power of 0 is always 1. So q to the power of 0 is just 1, so we get p times 1, which is just p. So 8 is equal to p. Then we look at the second equation here. We've got y equals pq to the power of x. Our y coordinate is 18, and this is equal to p, which we know, which is calculated as 8, multiplied by q to the power of 1. So this is equal to 18 equals 8q. So we can solve for q by dividing both sides of the equation by 8. So 18 over 8 is equal to q. So q is equal to 9 over 4. And then if we look at the third equation, we've got y equals pq to the x. We know that y is equal to k. P is equal to 8 multiplied by 9 over 4 to the power of x. So now we can solve for k. We know that x in this case is 1.5. So if we type this into the calculator, we've got 8 times 9 over 4 to the power of 1.5. So this is equal to 27. So p is 8, q is 9 over 4, and k is 27. The final question is question 10, and it says make x the subject of the formula. So we're going to expand this right hand side here to get 2x plus a is equal to bx minus 2b, and we're told we need to make x the subject of the formula. So we need all of the x's on one side and then everything else on the other. So let's move all of the x's to the left hand side. I'm going to subtract bx from both sides to get 2x minus bx plus a is equal to minus 2b. And then we're going to move this a to the other side by subtracting a from both sides to give us 2x plus bx is equal to minus 2b minus a. And then I'm going to take a factor of x out to the front and factorize this to give us x brackets 2 plus b equals minus 2b minus a. And then this is x times 2 plus b. So I'm going to divide both sides of the equation by 2 plus b. And this will give us x, which is equal to minus 2b minus a over 2 plus b. You could also have this as x equals a plus 2b over minus b minus 2. So if you change all of the signs, but usually I would just stick with this initial answer. So x is equal to minus 2b minus a over 2 plus b. So this concludes the video on grade 6 to 7 revision set A. Remember to drop a like and subscribe to the channel for more videos like this.